everyone, how are you doing? I hope everyone is doing good. So welcome to another video of inheritance and variation. We were doing sex-linked inheritance in the previous video. We covered color blindness and hemophilia. In this video, we will talk about how the sex is determined in organisms like first we will do humans, then birds, and then honeybees. So straight to the humans. This is very simple. This you have studied in lower standard also, and then we have been studying in past few videos wherein we are discussing time and again that the male will have one X and one Y, and the female will have two X, right? Two copies of X chromosome in females, and in males one copy of X and one copy of Y. So this will determine the sex of the baby or the individual. Fine. So in this humans we call it as XX and XY mechanism. Male is heterogametic, that is different gametes are there. One is X and one is Y. Whereas female, so hetero stands for dissimilar, and female is homogametic, that is only X type of chromosome. Two copies of X chromosome will be there in a female, right? So it's like this. So you have your 44 autosomes, number of autosomes, and the male will have one X and one Y, and the female will have the normal 44 autosomes, the other chromosome, and the female will have two X. So the sperm will either be of X, the gametes will have 22 autosomes and X plus 20 plus X and 22 autosomes or Y. Whereas the egg will only be of this type. Sperms can be of two types, having either X chromosome or a Y chromosome. So if the male contributes X, then see the female is always contributing X only to the offspring. If the male contributes X, then X together becomes a daughter, and if the male contributes Y to the X, then it will become contributes Y to the X, then it will become a son. Okay. So here in humans, the sex is determined by the male, basically, whether it will be a boy or a girl. Similarly, in Drosophila is the same case. Okay, the female is homogametic and the male is heterogametic. Okay. So humans have 23 pairs of chromosomes, that is 22 pairs of autosomes and one pair of sex chromosome, right? That is in males, the eggs will all have the XX chromosome, and the sperm can either have X type of chromosome or Y type of chromosome because these gametes are haploid in nature. Okay, so a pair of X will be present in female and X and Y chromosome will be present in male. And during spermatogenesis, male will produce two types of gametes, that is 50% with X chromosome and 50% with Y chromosome. Fine. So if 2X, then daughter will be born. If 1X and Y, 1X and Y, then sons will be, male child will be born. Okay, that will be decided by the father only. So female produces only ovum with an X chromosome, and there is an equal probability of fertilization of ovum with the sperm carrying X or Y. So the egg which is having X chromosome has equal probability of the sperm carrying X chromosome or Y chromosome. There is no difference in between both the two. So whoever is whichever sperm with X or Y is capable of entering the X, so that type of zygote will be formed. So if X plus X, a daughter will be formed. If X plus Y, if the sperm of Y chromosome is able to penetrate the egg, then the son will be born. Okay. So this is about humans. So the sperm will determine whether the offspring will be male or female. This you need to know. Okay. In many cases, earlier there was, abortion of female, and it was thought that it is because of females that a daughter or a son is born. But no, it is because of the male sperm. Which type of sperm unites with the egg, whether carrying X copy of chromosome or Y. So that he will determine whether the baby will be male or female. Okay, so it's upon the sperm. Fine. Now in honeybees, it's very interesting. So you will see these two numbers over here. In honeybees, the diploid condition is 32. In humans, the diploid condition is what? 2n. That is what? 40. Total number is 46, right? 46 number of chromosomes. So 44 plus 1 sex chromosome. Sorry, 22 plus 1. If we talk about the number of chromosomes, right? Here the number is 32 in case of diploid and 16 in case of haploid. Okay. So it is based on the number of set of chromosomes. So here the type will not matter, the number will matter. The number of sets of chromosome will matter depending upon how many number of chromosomes are there uh, that the baby honeybee receives. Okay. So an offspring formed from the union of a sperm and an egg develops as a female. So this is very important under honeybee. A honeybee will be formed, a baby honeybee will be formed when, what type of honeybee? Female. So when a sperm and an egg unites, so a sperm and an egg, when they come together, they will make a female honeybee. They will make a female honeybee, and this female either can be a queen or a worker honeybee. This we will see in a short while. The difference between the queen honeybee and worker honeybee. Okay. So when the sperm and the egg unite, when they come together, a female honeybee is born. So this is what this condition will be what? Diploid. And what is the number of chromosome in diploid condition? 32. Okay. Then in which case will the male will be born? In which case will a male will be born? A male, an unfertilized egg develops into a male honeybee. So only this egg, if it is not fertilized by a sperm, if this egg is not fertilized by a sperm, it will develop directly into a male. So the number of chromosomes will be what? Haploid, 16. This is known as parthenogenesis. So this is very interesting. There is no type of gamete as such, which type will go into which progeny, and depending on that, male or female will be born. This is simply because on the number of sets of chromosomes. If fertilization happens between sperm and egg, so diploid condition is met. So females are diploid in nature and males are haploid. So if the egg directly develops into a honeybee, then it will be a male unfertilized egg. So no union. So the gamete number will be what? Haploid. After number of chromosomes, 60, 32 ka half is 60. So this is the type of sex determination in honeybees. What about in birds? Birds, it's opposite. It's opposite to the humans. Male are homogametic and female are heterogrammatic. Yeah. So in humans, male were X and Y, hetero, and female were homogametic, XX. But here the case is opposite. Male is homogametic and female is heterogrammatic. Here we represent the letter ZZ for male and ZW for female. So all the males will produce, all the sperms will be of Z only. Now female can produce egg with either Z sex chromosome or W chromosome. And here the female will decide whether the bird is going to be a male or a female. So again the same cross, but here the heterogeneity will be contributed because of what type of egg is the sperm will take in. So if this egg unites with this sperm, so ZZ male will be born. If the W wala egg unites with the sperm, then a female bird will be born. Okay, so that's about sex determination in birds. So it is ZW mechanism. Male is homo, that is two similar copies of the sex chromosome ZZ, and female will be hetero, that is one Z and one W. Okay. And XXXO and XXXY mechanism show male heterogamety. This is the example of the human. So exactly opposite to the birds. Okay, and this ZZZW mechanism shows female heterogamety. This is in humans, that male will determine the sex of the newborn, and in birds, the female will determine the sex of the newborn. Okay. Now we move on to the difference between the worker honeybee. So as we had discussed that females are diploid in honeybees and males are haploid. Females diploid 32 chromosomes, males are haploid 16 chromosomes. This is also known as haplodiploid sex determination system. It is also known as haplodiploid sex determination system in honeybees. So this term you have to remember in case of honeybees, haplodiploid. Okay, so the female will be diploid in nature, the male, the drone will be haploid in nature. Okay, so now this eggs, if it unites with the eggs of the male, then diploid condition, that is egg fertilized, a female honeybee is formed. This is female, right? Now, if this female baby honeybee, if if given a certain type of food, okay, which is known as royal jelly, if this female is fed with this royal jelly, she develops into a queen honeybee. If she is not given that royal jelly as a food, okay, as a supplement or as a food, then she develops into a worker honeybee. That is, she will be sterile. She will not be able to make eggs, okay, to carry on the generation. So queen will be fertile, whereas worker is only working. She will be sterile. And then if this type of eggs, which is not fertilized, if it is fertilized, and two scenarios can take place. If you give that female royal jelly, a queen will be formed. If you feed that baby honeybee, if you do not feed royal jelly to that baby honeybee, she will develop into a worker. That is, she will become sterile. And then if the egg remains unfertilized, so that will automatically develop into a male honeybee. Okay, simple to understand. So males produce sperms by mitosis because there is no union of gametes. So they will just simply do mitotic division in the gametes also. Okay, they do not have father and thus cannot have sons, but have a grandfather and can have grandson. So they are coming from the mother basically. You can see over here, right? So you have a queen, the gametes get separated, and then this haploid, if it's not fertilized, then it automatically develops into a fertile male. And then this fertile male, if if unites with one of the gametes with the queen, of the queen, then it develops into a female honey. So that was all regarding the sex determination in humans, birds, and honeybees. In the next video, we will be doing about genetic disorders, that is thalassemia, Down syndrome, Turner syndrome, and Klinefelter syndrome is also there. So this will be the last part of the chapter wherein the disorders related to human genetic disorders will be discussed. So till then, keep revising. Take care. See you in the next video.